Hello everyone. Welcome you all to post-contest discussion of Codeforces Round 982 Div 2. So, let's start with the discussion. We will be discussing 4 problems, and here is the first problem for you all. So, the name of the problem is rectangle arrangement. You are coloring an infinite square grid in which all cells are initially white. To do this, you are given n stamps. Each stamp is a rectangle of width Wi and height Hi. Now you will use each stamp exactly once to color a rectangle of the same size as the stamp on the grid in black. You cannot rotate the stamp, and for each cell the stamp must either cover it fully or not cover it at all. So you can use stamp at any position on the grid even if some or all the cells covered by the stamping area are already black. So the question is that what is the minimum sum of parameters of the connected regions of black squares you can obtain after all the stamps have been used? So let's understand what actually the question wants us to say. So in the question, you are given an infinite square grid which is initially colored white. Okay. And then you are given n stamps. Now every stamp has some width Wi and has some height Hi. So every stamp is rectangular in shape and has some height and width. Now what you are doing is you have an infinite square grid which are initially colored white. Now what you will do, you will take this stamp, keep this stamp somewhere. And when you do this, the entire area that this stamp is covering, it will be painted black. Okay. So entire area that the stamp is covering, that will be painted black. And it is given that if let's suppose you have a stamp and if let's suppose you have another stamp. So it is possible that you put the other stamp over the area that is already colored black. Like for example, this area was colored black. Now you put another stamp over this like this. And you can see that I have put this stamp so that some area has color white, some area has colored black. So it is allowed. You can place a stamp over the black colored square as well. So the question is that what is the minimum parameter? Or sorry, what is the minimum perimeter of connected black region that you can obtain? This is the question. Like for example, if I take an example, if let's suppose there is an infinite square grid and I have two rectangles, one rectangle has height as 1 and width as 5, and the other rectangle has height as 2 and width as 3. So I can place these rectangles like this. The rectangle of area height 1 and width 5 like this. Height 1 and width 5. And another rectangle of height 2 and width 3, something like this. So height 2, width 3. So you can see the perimeter of this is actually what the perimeter is, right? This thing, this. This will become your perimeter. And if you calculate this perimeter will come out to be 3 plus 5, 8, plus this value is 3, this value is 5, this value is 1, this value is 2, this value is 1, and this value is 3. So if you calculate it, it will come down to 16. Just you can calculate it is 3 plus 5, 8, 9, 10, 11, 12, 13, 14. Just a minute. Have I missed something? Oh, it is 1. Oh, it is 2. Yeah. So the perimeter will come out to be 16. And you can check other examples. You can place the stamp something like this as well. You can place it one stamp over here, the other stamp over here, something like this. And you will see that this is the case when you are getting the minimum perimeter. So the question is that what is the minimum perimeter you can obtain? Is the question clear? Anyone having doubt in the problem statement? Anyone, guys? No? Great. So how we can solve this? So the main thing is that we need to minimize the perimeter, right? Okay. So if I tell you that I have a rectangle that was placed something like this, I placed a rectangle like this. Let's suppose it had height as 5 and width as 3. And now I have other rectangle that has the width as, let's suppose, 6 and height as, let's suppose, 3. Okay, I have other rectangle like this. Now, where will I place this rectangle? Just observe one thing. You will have width as 6. So, and your height as 3. So, if you place this rectangle somewhere over here, anywhere over here, then you will see that the perimeter will be 5 plus 3, 8. So perimeter of this rectangle will be 16 and perimeter of this rectangle will be 18 with width as 6 and height as 3. So the total perimeter will come out to be 34, but you don't want the perimeter to be maximum. You want to minimize the perimeter. So what you can do is, you can place the other rectangle like this, so that you want to keep this rectangle as much as possible inside the rectangle already drawn. So what you will do is, you will put your rectangle something like this. So that the width of this rectangle is 6. We can't stop it from extending the width of the earlier drawn rectangle because its width is greater than the earlier drawn rectangle and its height remained as 3. So something like this we will do, and this we will do for each and every rectangle. We will try to keep each and every rectangle as much as possible inside the previously drawn rectangle. So do you all agree that I will have cases something like this, right? I will end up something like this. The outer boundary will look something like this. After I draw all the rectangles, the outer boundary will look something like this. Can someone say me what will be this value? What will be this value? Can someone say me? What will be this value? Do you all agree that this value will be maximum of all heights? Do you all agree that this value will be maximum of all the heights of the given rectangle? Similarly, can I say that this value, can anyone say now, what will be this value? Can I say that this value will be nothing but maximum of all the widths of the given rectangle? Right? So now can I calculate the perimeter of this given shape? If you observe, the perimeter of this given shape will be twice the, if I say this as h1 and this as w1, then it will be twice of h1 plus w1. As you can see that what we are adding in perimeter, this value, this value, this value, this value, this value, and this value. So this value and this value is actually equal to this value only. So this value is getting added twice, and this value and this value is actually equal to this value only. So this is also getting added twice. So the answer will be twice of maximum of all heights plus maximum of all widths. Is the logic clear? Is the logic clear? Yes. So let's see the code quickly. So I was thinking something like this, something different in my contest. But what you can do is, you can just maintain two variables, maxi1 and maxi2. Take heights and widths as input. Change your maxi1 to maximum of given height, comma maxi1. So basically, your maxi1 will at the end store the maximum height, and your maxi2 variable will at the end store the maximum width. So your answer will be twice of maxi1 plus maxi2. Just ignore all these if statements, just ignore this thing. Your answer will be twice of maxi1 plus maxi2. I was thinking something different in the contest, so I wrote like this. But as we discussed the logic, the answer will be twice of maximum heights plus maximum width. So this will be your answer. Is it okay? So Sean, I would recommend that you just go through the problem statement once by yourself so that you will be able to understand. Just skip this for now. And once the discussion is over, what you can do is you can just go through the problem statement once again, and then you will be able to correlate with the solution that we discussed. Is it okay? Today. Any other doubt, guys? Basically, your maximum will be storing the maximum height, maxi2 will be storing the maximum width. Your answer will be twice of maximum maxi1 plus maxi2. Any doubt, guys? No? Great. So let's move on to the second question. So the name of the question is Stalin's short. So Stalin's short is a humorous sorting algorithm designed to eliminate elements which are out of place instead of bothering to sort them properly, lending itself to a big of n time complexity. So just ignore this statement. So it goes as follows. Starting from the second element in the array, if it is strictly smaller than the previous element, ignoring those which have already been deleted, then you will delete it. So you can delete every element that is strictly lesser than its previous existing element. So continue iterating through the array until it is sorted in non-decreasing order. For example, the array 1, 4, 2, 3, 6, 5, 5, 7, 7 will become something like this. Let's see how. So your second element is greater than the first element, so you will not delete this. Your third element is actually lesser than the second element, so you will delete this element too. So now your 3 is lesser than 4, so you will delete this 3 as well. Then your 6 is not lesser than 4, so you will not delete this 6. So after 1 and 4, the next element that will come is 6. Now for 5, you will delete 5 since 5 is strictly lesser than 6. This 5 will also be deleted since it is strictly lesser than 6. Then you have 7. So 7 will not be deleted since it is greater than 6. And similarly, this 7 will also not be deleted. So if you just apply Stalin's short in this particular array, it will become something like this. So we define an array as vulnerable if you sort it in non-increasing order by repeatedly applying a Stalin's short to any of its subarrays as many times as is needed. So given an array A of n integers, you need to determine the minimum number of integers which must be removed from the array to make it vulnerable. So by a vulnerable array, we mean that we can sort it in non-increasing order, basically in descending order, by repeatedly applying a Stalin's short to any of its subarrays. And the constraints given in this problem was like n is of the order of 2000. So basically n square solution will always work. So you can brute force your solution. But first of all, let's discuss what the solution can be and what's the question is. Okay. So the question says that let's suppose you have an array. Let me take the example from this. 3649252. 3649252. Now, first of all, let's discuss what is a vulnerable array. Okay. So let's discuss what is first of all a vulnerable array as in the definition. So vulnerable array is something like this. Let's suppose I give you an array something like this. 6, 2, 4, 6, 2, 4, and then let's suppose 9, and let's suppose 3. So this is a vulnerable array. Why this is a vulnerable array, or is this not a vulnerable array? Let me remove this. Okay. So this is a vulnerable array. Why I am telling that this is a vulnerable array? See, let me take this. So if you can take any subarray and do Stalin's short in that. After doing this in any subarray, any number of times, if you are able to change this array into non-decreasing form, if you are able to change this array into non-increases, just a minute, into non-increasing form, then you see that the array is vulnerable. Okay. So for example, first of all, let's understand what is Stalin short. So let's suppose I have an array something like this, 6, 4, 2, 9, 3. So if you apply Stalin short in it, so what basically happens is, if you are at any element and the element's value is actually lesser than the previous element value, strictly lesser than the previous element value, then you will remove that element. Like for example, in this particular array, I was at 4 and 4 is strictly lesser than 6. So I removed this 4, I moved on to 2. Then again 2 is strictly lesser than 6. So I will remove this 2. Then I move on to 9. This 9 is not lesser than 6, so I will not do anything with this 9. Then I move on to this 3. This 3 is strictly lesser than 9, so I will remove this 3. So after this, just observe, my array becomes 6 and 9, which is actually shorted in non-decreasing or basically increasing order. So this is what we mean by Stalin short. So the question says that the array is vulnerable if you can do Stalin short in any of the subarrays any number of times and make this array non-increasing or basically in decreasing order. So just observe, I can always do Stalin short in it and make this array as non-increasing, because I can select this subarray first of all. I can select this entire subarray actually. So just observe, I will be able to remove this 2 because this 2 is strictly lesser than 6. I will be able to remove this 4. I will be able to remove this 3 as well. So I will be left out with only 6, which is definitely in non-increasing or basically in decreasing order. So I can see that this particular array is vulnerable. So the question is that you are given some array. You are given some array A1, A2 up till AN. The question asks you that what is the minimum number of elements you need to delete from this array so that this array becomes vulnerable. Like for example, if I give you this particular array, in this case, you have to remove this 9 to make this array non-increasing. Otherwise, you can't make this array vulnerable. Because see, with the help of this 6, I will be able to remove this 2 and 4, but I will never be able to remove this 9. Right? I will never be able to remove this 9. So I will have this 6 and 9 left. I will be able to remove this 3. So this array is actually not non-increasing. It is an increasing array. So this is not what we want. So if we remove 9 from here, now you can see with the help of 6, you can remove this 2, 4, and 3, and this array will become non-increasing. So the question asks you that what is the minimum number of elements you need to delete so that the array becomes vulnerable. So is the problem statement clear? Yeah, doing a Stalin short on any subarray, like for example, let's suppose I have an array. I have a subarray like this, 6, 4, 2, 9, 3. So if I am doing a Stalin short in this subarray, so with the help of this 6, this 4 will be removed, then this 2 will be removed. Yeah, I took a test case. Sam. This particular test case was taken. Okay, I am explaining once again. See, if I am doing a Stalin short in this particular subarray, so with the help of 6, this 4 and 2 will be removed. Then this 9 can't be removed. Then with the help of this 9, this 3 will be removed and I will be left out with 6 and 9. This is what Stalin short means. So is the Stalin short clear to everyone? Yes. So the question is that what is the minimum number of elements you need to delete so that you make this array as vulnerable? By vulnerability, we mean that if we are selecting any subarray and doing Stalin short in it, and we can select any subarray any number of times, then after doing Stalin short, the array should be non-increasing. Like for example, if I take this example, 3649252, 3649252, then just observe. If I, let's suppose, take this particular element, if I, let's suppose, decided that I will delete this 9, I will delete this 3, and I will delete this, let's suppose I don't delete any other element. So I will be left out with 64252. And I can say that this array is vulnerable because, see, I can select this subarray. With the help of this subarray, if I just apply vulnerable short in it, I will be able to remove this 4 and 2. And then I will be left out with 6, 5, and 2. And this array is non-increasing. So after removing these two elements, I was able to form a vulnerable array. So the answer to this statement will be 2. Let me just confirm what was the answer. Yeah, so the answer was 2. The minimum elements that you need to delete is 2. You can, if you remove any other elements, you can just see this is the case. This is the one with minimum case. If not, delete 3. If you don't delete 3, then what will happen? See, you will be having 3, 6, 4, 2, 5, 2. Now, is this array vulnerable? Is this array vulnerable? No, right? Because you can't select any subarray and apply. Yeah, you can't select any subarray and apply short in that, and you will be able to get a non-increasing array. So it's never possible. We take array as input and then we perform short algorithm. No, Shine, you have misunderstood the question, I think. What you're doing is, the question is that what is the minimum number of elements you need to delete such that the array becomes vulnerable. And by vulnerability, we mean that if we can select any subarray any number of times and do a styling short in it, we will be able to get. I already took that example, Shayan. This was the example, no? Test case 1. I already took it. Now tell me, what is your doubt in this? It can be in descending, yes. Descending means, non-increasing means descending. In this, if I remove this 3 and 9, in this particular array, if I remove this 3 and 9, I will be left out with 6, 4, 2, 5, 2. Agree? I will be left out with this. Agree? Anyone having doubt in this? If I remove 3 and 9, I will be left out with this. Shine, are you having doubt in this? I didn't apply any short. This was the input given to me. 3, 6, 4, 9, 2, 5, 2 was the input, right? Or am I taking it wrong? 3, 6, 4, 9, 2, 5. 3, 6, 4, 9, 2, 5, 2. I am given this input only, Shine. I am given this input. Now let's suppose I delete this 3 and 9. I can delete any number of elements. What you did to input. This is the input. 3, 6, 4, 9, 2, 5, 2. Okay, wait. I am allowing you to unmute. Tell me your doubt. I am deleting any random element. I am just explaining you how the answer to this test case is 2. So
Okay,
I deleted it. Yes.
okay, so you took an array, okay, and then how, like, what is the intuition behind like deleting 3 and 9? Like, what you thought of,
We
like,
will discuss. We
why
will
you're
discuss.
deleting
Now
3 and
I
9?
am just explaining that how the answer for this particular array is 2. That is the only thing that I am explaining right now. I'm
Okay,
not explaining any intuition or anything like that.
okay, got it.
Okay. So if I delete this 3 and 9, are you clear that I will get my answer as 2? I will, the remaining array is vulnerable. Do you agree with me in this? This array 64252 is vulnerable. Any doubt in these guys that how the answer for this particular test case is 2? Any doubt till now? Is the question clear? Like, that is the important point. We have not yet discussed the solution. So let's not jump to the intuition and all. But is the problem statement clear? Anyone having doubt in the problem statement? No, right? Good to go? Okay, yeah. So how we can solve this? So there is one observation. Since you were given n is of the order of 2000, so solution something like n square will always work, right? Big O of n square solution will always work. So what I thought of was, let's fix our first element. Now, do you all agree that whatever subarray I am selecting and I am doing Stalin shortening, the first element of the array will never be deleted? Let's suppose I was given the array as A1, A2, A3, A4, A5, A6, A7. And I decided that I am going to take A3 as my first element. I am going to start my vulnerable array with A3. Basically, I am deleting this A1 and A2. So do you all agree that now whatever array I form, let's suppose I formed this as my vulnerable array. So do you all agree that whatever subarray I select, I will never delete the first element? The first element will remain as it is, right? It will never get deleted, because whenever we do vulnerable short or whenever we do Stalin short, the first element never gets deleted. The deletion starts from the second element or the third element or the fourth element. The first element never gets deleted. So if I am fixing the first element, so this first element will remain in the final non-increasing array as well. Do you all agree with me in this point? Anyone having doubt in this? Yes? So I did this thing. I tried fixing all the elements at the first element and then I calculated the answer. Now let's suppose I tell you that I am fixing A3. So definitely I am deleting A1 and A2 because I decided that A3 will be my first element. Okay. Now what all elements to delete over here? Just see. Just tell me one thing. Can I delete any element? Can I keep any element that is greater than A3 in my vulnerable array? Just listen to this question once again. Can I keep any element? I have decided that A3 will be my first element. Okay. So can I keep any element greater than A3 towards right of A3? Can I do this? And why I can't do this? I can't do this because I want to keep my array non-increasing, because so after doing Stalin short, all the elements towards right of A3 should be lesser than or equal to A3, right? All the elements towards right of A3 should be lesser than equals to A3. Now, if I am having any element greater than A3 in my vulnerable array, so I will never be able to delete it. And that's the reason I can't keep any element greater than A3 towards the right of A3. And can I keep any element lesser than A3 towards the right of A3? Can I keep any element? Can I keep any element lesser than equals to A3 towards the right of A3? I can.
Yes.
Because I can always delete those elements. With the help of this A3, I can always delete those elements if I select this as my subarray. And hence I can say that I will be left out with only A3, which is definitely a non-increasing array, right? So the logic is very much clear. I will fix my first element. I will fix my first element. So I know that how many elements I am deleting from the left. And then after fixing the first element, how many elements I am deleting with right is basically what I can do, run a for loop from this index to this index and check how many values are actually greater than this particular value. I can just delete those and I can say that these are the total number of elements I need to delete. No, Mohit, I am deleting every element from the left because I am telling that I am starting my array from here. I am exploring all the options, right? So it does not matter that if I need to delete all the elements from the left or not. I am exploring all the possible options that my array, vulnerable array is starting from here, my vulnerable array is starting from here, my vulnerable array is starting from here. I am exploring all the options. So it's not an issue. Even if this is wrong, like it will give me more operations or more deletion operations, then definitely I will get a minimum one when I take minimum of all. I am taking minimum of all. I am taking minimum when I am selecting this as my first element. I am taking minimum when I am selecting these as my first element and this as my first element. I am taking every element of the array as the first element and then calculating how many deletion operations I need to perform. Is this thing clear? Anyone having doubt in the approach or the logic? Now, Shayan, is this clear, like why I decided that I am going to delete this 3 and 9? Because I decided that I am going to start with 6. So I deleted 3. And towards the right of 6, I need to delete every element that is greater than 6. So that's the reason I deleted this 9. So that was the reason that I deleted these two numbers. Is the approach and logic clear? Should we jump onto the code? Yes, Sam. You can unmute yourself as well.
So sir, we are doing like for example, if we are like we are in at index any index, so from that index plus I index plus 1, we are trying to delete the all element greater than current element, right?
Yes.
And
And
what
we are
about
also
the
deleting all the elements towards left as well because we have decided that that is the element where our vulnerable array is starting.
okay, so we will delete the elements which is greater than the current element, and in the left side we will delete the element which is less than current
No, in the
element,
left
right?
side, we are deleting all the elements because we have decided that our vulnerable array is starting from this particular point.
Okay, got it. Thank you, sir.
So if you start with 4, yeah. If I let's suppose start with 4, so I will delete this 3, I will delete this 6 because all the elements towards the left, and in the right I will delete this 9 and I will delete this 5. Is it clear, Mohit? Yeah, minimum is 2 actually. Minimum is 2. Because
No,
this was when
if
I
you
selected 6 as my first element. So what I am doing is I am selecting every element as my first element and taking minimum answer of all. That's what I am doing more. So
so
though,
what
yes,
I'm asking is that if you start from 4, like let's just forget about the previous elements. If you start from 4, then you would delete 3 and 6 and 9 and 5, right?
yes,
But for 4, considering the minimum deletions, it would be 3 deletions, correct? Like you would delete 3 and 9 and 5.
3, 9, and 5. Yes.
So 4 and 3, then like would it work for all test cases is my answer. Like from the left, from the right, that I'm clear
Yeah,
that I
see,
would delete the maximum.
when I told you, like this was a question someone else raised as well. Like if you are fixing this first element, so you don't need to delete all the elements towards the left. But then our definition becomes wrong that I am considering this as my first element. So when you are telling that you are considering 4 as your first element, then how will you not delete this 6?
Yes,
So
I
the
got
way
it.
you
I
are
got
telling
it.
that you don't need to delete this 6 is the one when you are considering 6 as your
6
first
as the
element.
first element. Yeah.
So
Okay.
in that case, we were not deleting this 4 and we were getting our minimum answer, right?
Yeah.
So you need to consider all the cases. So I am considering all element as my first element and then working with that. Is it clear now, guys? Any doubt?
एक्सक्यूज मी सर,
Yes.
इस क्वेश्चन के लिए एक डिफरेंट अप्रोच आई थी, हम वो बाद में डिस्कस कर सकते हैं क्या?
Okay, if time permits, we can discuss.
ओके, थैंक यू.
So let me jump onto the code. So the code will be pretty much simple. I am just initializing. I just took the inputs of all the numbers, the size of the array and input of all the numbers, initialized my answer to n. Then I just try to fix all my elements as the first element one by one. So I ran a for loop for that, and I am fixing the ith index as my first element. Then I am seeing that how many elements I need to delete from right. So I initialize that result with 0, and just I am going for I plus 1 till less than n j plus plus. If the element at index j is greater than the first element that I have decided, that is v of I, so I am just incrementing my result. So the total number of deletion operations that I need to perform is result plus I. I why? Because if I am selecting I as my first element, so towards the left, since I am considering I as a zero-based indexing, so towards the left, I have I elements. So I elements of deletion towards the left, res number of deletions towards the right. So total number of deletions is res plus I. So I'm taking minimum of all the cases and I'm just printing my answer. Is the logic and code clear? Any other doubt, guys? Yes. Anyone else? Any doubt? Clear? So let's jump on to the third one. So actually the second one today was a bit like what I felt was, yeah, the same. Like even I was not very much confident in the second one in today's contest, and it took me a lot of time actually. And C and D1 were solved, I solved pretty fast, but B took me some time. So it was a bit weird for today, but okay, that was it. So let's discuss this C question. So you are given an array A initially containing n integers. In one operation, what you can do is you can choose a position I such that I is greater than 1 and lesser than mod. Okay. So what does this mod A defines? This basically defines the size of the array A. Okay. So you can see there, this mod A is the current size of the array. So you can choose any position I such that I is greater than 1. So you can't select the first element. Okay. Just keep this in mind. I is greater than 1. So you can't select the first element. And if you are selecting any I, you can only select it when the value AI is equal to mod A plus 1 minus I. Then only you can select this AI. Now let's suppose you have selected this ith position. So what you will do is you will append I minus 1 zeros onto the end of A. Okay. So the question is that after performing this operation as many times as you want, what is the maximum possible length of the array A that you can obtain? So n is of the order of 3 into 10 power 5 and AI is of the order of 10 power 2. So let's see what actually the first of all, let's understand what the question is with the help of this particular example 2, 4, 6, 2, 5. So you are given initially 5 elements. The elements are 2, 4, 6, 2, 5. Okay. So what they have told? They have told that you can select any index I. So they have considered one based indexing. So this is index 1, index 2, index 3, index 4, index 5. So you can select any index I so that I is greater than 1, and definitely it should be lesser than equals to the size of the current array. And the AI value should be equal to mod A plus 1 minus I. If you are able to select such I, then just add I minus 1 zeros at the end of the array. So the question is that what is the maximum length of the array that you can obtain? This is actually what the question is. If we try to understand this via this particular example, if I let's suppose take my current length is 5, right? My current length is 5. Let's suppose I selected this particular element. Just give me a minute. I am seeing that which two elements should I select. So this will be 4. This will give me an increment of 3. And okay, this will give me an increment of 2. This will give me an increment of 1. And this will give me an increment of 4. Okay. So let's see what we can do. First of all, tell me that if I am selecting this particular element, the element present at index 2, what should be my length of the array? So if you observe, ai should be equal to mod a, that is the length of the current array, plus 1 minus I, right? So from here, can I say that the length of the array is equal to ai plus I minus 1? Can I say this? Can I say this? Anyone having doubt in this? Anyone having doubt in this? That the length of the array should be equal to ai plus I minus 1? No? So can anyone say me, if I am selecting this element, I can't select the first element, it's already given. Okay. If I am selecting this element, can anyone say me what should be the length of the array? What should be the length of the array if I am able to select this particular position? Seven.
Six.
No. 5, right? Just do a simple calculation. ai plus I minus 1. 4 plus 2 minus 1 will be 5, right? How you are getting 6? The length of the array should be equal to ai plus I minus 1. This is given to you. So from there, I just took this all this 1 and I towards the left and just rotated this and wrote this. Is this equation clear to everyone? Like it's already given to you. Right? So I can select this when the length of the array is 5. Do you all agree with me in this? Anyone having doubt in this? Do you all agree with me in this, with this 5? Yeah. And if you are selecting this, then tell me the number of zeros that you will append. You will append 1 zeros, right? Do you all agree with me in this? Yes. Similarly, tell me, if I am selecting this element, what should be the length of the array? 8. 3. How 3? Length of the array is ai plus I minus 1. How 3, Sam? ai is 6, I is 3. 6 plus 3 minus 1 is 8. How come 3? Yes. And tell me the number of zeros it will append. If I am selecting this position, how many zeros it will append? If I am not wrong, it will append 2 zeros, right? It is appending I minus 1 zeros. Do you all agree? Similarly, tell me that what should be the length of the array if I am selecting this position? What should be the length of the array if I am selecting this position?
5.
5, right? And how many zeros will it append?
3.
3, correct. Similarly, what should be the length of the array if I am selecting this element? 9. And the number of zeros it will append? 4. Is this thing clear to everyone, whatever I wrote over here? Is this thing clear to everyone? Kindly let me know if anyone is having doubt in this. Then I need to explain it again. But tell me, is this thing clear to everyone? Whatever I wrote over there. So this is actually demand. And this is actually the increment. Right? This is actually the demand is the size of the array should be exactly like this. And if it is, I can select this element and I can increment the size of my array by 3, basically appending 3 zeros at the end. So let's see what is the maximum size of the array I can obtain over here. So the array given to me is 2, 4, 6 to 5, right? So let's suppose first of all I select this element, this position. So the demand of this position is that the size of the array should be 5, and it is 5 currently, right? So I can select this position, and once I select this position, I can clearly notice that it will append 3 zeros at the end. So I appended 3 zeros. So the length of the array becomes 8. So I can see that now I will select this particular position. The demand of this particular position is that the size of the array should be 8. So I can see that yes, the size of the array is 8. So what it will do, it will append 2 zeros. So I appended 2 zeros. And now you can't select any other position. So I can definitely say that the maximum size of the array that I can obtain is 10. So the answer to this particular test case will be 10. So is the problem statement clear to everyone? No, it is not deeply good. We will discuss it. It's completely greedy. So is the problem statement clear to everyone? Anyone having doubt in the problem statement?
सो वाई इट इज नॉट डीपी, क्योंकि हर बार तो हम देख रहे हैं ना कौन सा ऐड करना सही रहेगा.
No, DP is not possible. We will discuss it. Maybe we can do it via DP, but I have to think of that. But greedy is straightforward. Like we will discuss it. Once you know the solution, you will say that, oh, it was so easy. But before that, is the problem statement clear to everyone? Anyone having doubt in the problem statement? No? Great. So how we can do this? Okay. So one thing in observation over here was, we can't select these as my positions. When we are appending zeros, so don't think of taking this as my position, because you will never be able to do that. Because if we take this as our position, what is the demand that the size of the array should be? The AI becomes 0. The size of the array should be I minus 1. But if you are having this element, this means that you have the size at least I, right? So you can never take these zeros as the positions. Do you all agree with me in this? Do you all agree with me in this, that I can't select these zeros as my positions? Anyone having doubt in this? Yes, great. So how we can proceed? So just tell me, if I am telling you that I didn't apply this operation. Let's suppose I am still left to take this in position. I have not taken this position yet. And before that, I took this position. I have not taken this position yet, but before that, I took this position. So tell me, will I ever take this position? Tell me. What does this demands? This demands that the size of the array should be 8. What does this demands? This demands that the size of the array should be 5. So if it is 8 and we are incrementing the size, then can we after that take this particular position? Can I take this particular position after this? Because this demands that the size of the array should be 5. But it was 8 earlier only, and we increased it by 2. The size became 10. So we will not apply this operation after this particular operation. Do you all agree? Do you all agree with me in this? Anyone having doubt in this? That I will never apply this particular operation first before this, right? So what does this means? This means that I will always apply those operations first that have the lesser demand value. Do you all agree with me in this? First, I will always apply those operations that have lesser demand. Do you all agree with me in this point? Any doubt, guys, in this? Tell me if you are having doubt. Any doubt, guys? Yes, no, anything? What I told is, can we apply this operation and then this operation? Can I do this? Good, same. I apply this, I choose this in position first and this then this position. Can I do that?
सर मेरे दिमाग में जो चीज आ रही है वो ये है कि लेट से जैसे यहाँ पे 5 के हमारे पास दो हैं पेयर है ना जो 5 रिक्वायरमेंट कर रहे हैं
हम्म
और जो वो इंक्रीमेंट कर रहे हैं वो अलग अलग है। लेट से
हम्म
अभी हम सेकंड लास्ट एलिमेंट मानते हैं जैसे कि 8 और 9 हमारे लास्ट ही हैं एक तरीके से, उसके बाद कुछ है नहीं।
हम्म
तो ऐसा हो सकता है कि 5 से हम एक बार तो रहें एक अलग नंबर पे क्योंकि इंक्रीमेंट अलग अलग है। लेट से हम
जाने का जरूरत नहीं है. We will not go. Just tell me one thing. You will get the solution. I can understand what you are feeling. But before that, before jumping to the solution, tell me, can I apply this operation first and then this operation? Can I ever do that?
नहीं।
No, right?
यस।
So if I am applying any operation, so I will always apply the operation on the lesser demand first and then on the higher demand value, right?
यस।
So is this statement clear?
हाँ ये सब तो क्लियर है पर मैं वो कह रहा था कि
Okay,
ग्रेडी
okay,
का
okay,
नहीं समझ
okay.
में।
Wait. You will get this. So this statement is clear, right?
यस।
So can I short this value, this pair, whatever pair I have built? Can I short this pair on the basis of first value? Can I do this?
यस।
Okay. So let me short this on the basis of first value. 5 1, 5 3, 8 2, 9 4. This is what I will get my short. Yes. Now tell me one more thing. Can I choose one position more than once? Can I choose one position more than once? Because if let's suppose I am choosing a position, okay. So it demanded that the size, let's suppose I chose this particular position, it demanded that the size of the array should be 5. So if let's suppose the size of the array was 5 and I was able to choose this particular position. So what it will do? It will increase the size of the array by 3, right? So I will never get the size of the array 5 back again. So this means that if I have chosen a position, I will never be able to choose that position again. Do you all agree with me in this point? Yes? Okay. So tell me, what is the current size of the array? I have not performed any operations. What is the current size of the array? 5. Agree? Okay. Can I choose this particular position? Yes. What it will do? What will be the size of array become? 6. Great. Let's move on to this particular position. Can I choose this particular position? No. The answer will be yes. Because somewhere in past, I had the length of the array as 5, right? Somewhere in past, I had the length of the array as 5. So I can choose this particular position. It allows me. Do you all agree? It may be that I don't choose this particular position, and at first only I choose this particular position. It is possible, right? So can I select this particular position? Tell me now. Its demand is 5, and somewhere in past I had the length as 5. This means definitely I can select this particular position. Do you all agree? So what will be the length of array become if I am selecting this particular position? 8. Great. Can I select this particular position? Yes. What will be the length of array become? 10. Can I select this particular position? No. So these are the possible lengths of the array that I can obtain, and the maximum value is 10. So the answer will be 10. That's the solution to this problem. Understood? Any doubt, guys? Like I am just going over all the positions in increasing order of demand, and I am just seeing that whether I can select that particular position or not. And when I can select that particular position, only when I had that demand value as that demand value somewhere in the past. So I can definitely select that demand value and I will increase the size of the array. So any doubt, guys? Is the solution and approach clear? So I will jump onto the code then. So the basic intuition in this question was there were 2-3 things you need to look up. The first thing was you can never choose the 0 as the positions. The next thing was that you can't choose a position more than once. The other thing was that you will always choose position on the basis of increasing order of demand value. And then you can reach to this particular solution. These 2-3 things you needed to look up, and then you can definitely reach over it. Yes, it's a kind of a little bit of DP, but I would not name this as DP because I see this as a complete greedy approach. But yes, since you're remembering the past value, so you can say that a bit of DP is in. But even if you don't know DP, it is not needed over here. DP is not needed, right? Is the approach clear? Should I jump onto the code? So this was the code to this problem. First of all, I took n numbers as input. So I basically took the inputs in one-based indexing format. Then I constructed pair of LL, LL ARR. So since I can't select the first element, that is the element at first index, so I just started with second index. So in my array, I am pushing two values, the demand is b of I plus I minus 1, and the number of zeros it will append if I am fulfilling its demand. So the number of zeros it will append is I minus 1. Then I basically sorted the array on the basis of demand, constructed a set. I'm constructing this set so that it will help me basically to get that whether I had that particular demand in the past or not. So you can use map as well, not an issue. I just used set. And in my set, I inserted n because initially I have my array size as n. Then I went over all the positions from 0 till n minus 1 because the size of this array ARR will be n minus 1 because I appended for index 2 to n. So the size of this ARR will be n minus 1. So I went to all the index from 0 till n minus 2. If I have the demand value in my set, this means if I find ARR of I dot first in my set, that is st dot find ARR of I dot first is not equal to st dot n, then I know that I can fulfill the demand of this particular position. So I can definitely select this particular position. And once I select this particular position, what will be the size of array become? The size of array will become ARR of I dot first, that is the current size, plus the number of zeros this particular position will append to the end of the array, basically ARR of I dot second. So this will what the size of array will become, and I am simply inserting this in my set. Once I am done with this, the last value or basically the maximum value in the set is the maximum size of the array that I can form. So I am just printing the last value in my set, that is star st dot r begin, and I am done with it. So is the code clear? It is pretty much the same that we discussed. So any doubts in the code? Any doubt, guys? Should I jump on to the next one? Max value of second for each first. instead of using set. Max value. Second is not the size of the array that will become. Second is basically the number of zeros it will append. So the size of the array will be, if you're fulfilling the demand, the size of the array will be error of I dot first plus error of I dot second. I don't know what you're talking about. Directly using 5, 3, then 8, 2. But how will you directly use? Like, if you are using directly 5, 3, then from there you are talking, if you do a binary search, then you will be able to go to 8, definitely. But yeah, again, that will then become a question of DP with binary search. So you can definitely solve it by that as well. That every time you have a choice that whether you select a position or you don't select a position. So if you select a position, you can just simply do a binary search and go to the next possible position that you can select. So you can do that as well, but this is what I discussed greedy approach. Is it clear? So let me jump on to the next one. So the name of the question is the end speaker easy version. So the prerequisite for this question will be DP. If you guys, any one of you not knowing DP, then it will be hard to understand this question. So let me first of all go through the question. You are given an array A of length n and an array B of length m. Initially, the value k is equal to 1 is given to you. Your aim is to make the array A empty by performing one of the following two operations repeatedly. There are two operations, type 1 operations and type 2 operations. So type 1 operation is, if the value of k is lesser than m and the array A is non-empty, you can increase the value of k by 1. This does not incur any cost. So you can increase the value of k by 1 and you will not get any cost. The type 2 operation is you remove a non-empty prefix of array A such that the sum of the elements that you are removing should not exceed pk. So this gives you a cost of m minus k. So you need to minimize the total cost of the operations to make the array A empty. And if it's impossible to do this through any sequence of operations, you need to simply output -1. Otherwise, output the minimum total cost of the operations. So let's understand this with the help of this particular example. The array A given to you is 9343 and array B as 117. So you are given array A as 9343 and array B as 117. So size of array A is 4, size of array B is 2, and initially the value of k is 1. So let's see what are the operations that you can perform. So this is basically your value of m. And this is what your value of n. So you need to empty this array A. But how you can empty this array A? So what you can do is you can select any non-empty prefix of this array A and you can remove it from A only if the sum of elements that you are selecting is lesser than equal to B of A. So initially k is 1 and it is given to you that B is in non-decreasing order. Okay, it's already given to you. Oh, sorry, non-increasing order, basically decreasing order. It's given to you. So let's suppose I select the first thing with k is equal to 1. What I do is I select this particular prefix and I remove this from my array. You can see that I can select only this particular prefix. I can't select this because if I select this one, the sum will become 12, which is greater than 11. So I can definitely can't select this, right? So the maximum I can select is this one. So what I do is I select that prefix, remove it from my array, and tell me what is the cost. The cost will be m minus k. So m value is 2, k value is 1. So the cost will be 1. Okay. Now, my k was 1. This was when my k was 1. Now what I do is I increment my k. That is, I shift my k value to 2. So it's already given. This is a type 1 operation. And it's already given to you that if you are doing a type 1 operation, you are not incurring any cost. So your cost will not increase. Now just see over there. What you can do is, you can select this prefix over here. You can't select this entire remaining array as the prefix, because if you do that, the sum of elements will become 10, and which will be greater than the given value of b of k. So you can definitely can't select the entire element, but you can select this prefix because the sum is 7, which is not exceeding the value b of k. So what you can do is you can remove this 7 from the array. You can remove this complete prefix, and the cost will get incremented by m minus k. So the value of m is 2 and the value of k is also 2. So your cost will just get incremented by 0. So your cost will remain as 1. Then you can select this prefix, and definitely its sum is lesser than the value of bk. So you can definitely select this prefix, remove this, and again the cost of this will be m minus k. So basically 2 minus 2. So your cost will get incremented by 0. So the final cost you are getting is 1. And you can just see this is the minimum cost via which you can delete this entire array A. So the answer for this particular question will be 1. Is the problem statement clear? Is the problem statement clear, guys? Anyone having doubt in the problem statement? That how I got this 1 as my answer? Yes, no, anything. Is the problem statement clear? Yes? Yes from everyone? Like there are 6 people, I think, in the chat, in the meet. Yes? Great. Okay. So how we can solve this question? How we can solve this? Just see over here. When I was having my array A as 9, 3, 4, 3, and my array B as 11 and 7. So it's given to me that I am starting with k is equal to 1, right? So what are the options I have? I have one option that I do an operation something like this, that I first of all remove this particular prefix when my k was 1. In this case, the cost will be equals to 1. That is basically m minus k. So 2 minus k, which is 2 minus 1 equals to 1. Then you can see that I can remove this particular prefix as well with the value k as 1. I can do that, right? Because the sum of the elements is not exceeding 11. So I can remove this particular prefix. And in this case, my cost will be added by m minus k. So 2 minus 1. So the total cost I will get is 2. But you observe that I had a combination in which I was able to get the total cost as 1, and which is the minimum cost as well to delete this entire array A. So as you can see that there are multiple options you have. What are the options you have? If I am saying you that you are selecting the current k, if I say you that you are selecting the current k, you are selecting that, okay, with the help of this element of B, you are going to remove the elements of A. Let's suppose I told you that. So which elements can you remove? What are the options you have? So if I tell you that the array is A1, A2, A3, A4, A5, A6, then do you all agree that if I am at some particular k, so my sum, whatever sum I am taking, that sum should not exceed bk. Do you all agree that whatever sum I am taking, that sum should not exceed bk? So I can remove any contiguous subarray whose sum do not exceed bk. Just to repeat, I can remove any subarray whose sum does not exceed bk. And the cost for this will be m minus k. Do you all agree with me in this? That I can remove any subarray whose sum does not exceed bk. Do you all agree with me in this? I can remove this subarray, I can remove this subarray. Though in the question it is mentioned that you need to remove prefix only, but when I am talking that I am removing this subarray, so assume that I have already removed this subarray by some operations, by taking some k, I have already removed this subarray, and now I am removing this subarray. When I am talking that I am removing this subarray, so just assume that I have already removed this subarray. Right? Do you all agree with me in this point? Yes, no, anything. Do you all agree with me in this point? So I'm assuming yes, no answers. So I can remove any subarray, right? So I need to calculate that how many minimum costs that I will incur if I am deleting the entire array. So let me define a DP state, where DP of I will tell me that what is the minimum cost to remove all the elements from index 0 till I minus 1. I define my DP state like this. So can someone say me if the size of the array A is n, then what will be my answer? If the size of the array is n, then what will be the answer to this question? Do you all agree that the answer to this question will be dp of n? Because dp of n will tell me what is the minimum cost to remove all the elements from index 0 till n minus 1. And these are the only elements I have, right? This means that I am deleting the entire array. So do you all understand that what dp of I will tell me? Do you all understand this, that what dp of I will tell me? Yes? Okay. So tell me, what will be dp of 0? What will be dp of 0? What does dp of 0 tells you? dp of 0 tells you that you are removing elements from 0 till minus 1. Basically, you are not removing any element. So if you are not removing any element, so the cost will be 0, right? If you are not removing any element, so the cost will be 0. So now, if I tell you that I am at some particular k, and I want to remove the elements that are starting at index I. So how many elements I can remove? I can remove from index I can remove those elements whose sum is lesser than equals to bk, right? From index I can remove all the elements whose sum is lesser than equals to bk. And can anyone say me that from this particular index, can I know that what is the last index I can remove? Is there some mechanism via which I can know that what is the last index from this particular element that I can remove if I am at some particular k? I can simply do an upper bound, right? I know that if I have the prefix sum calculated, so I know that whatever sum I have till here, so the next index that I will not be able to delete will be nothing but the next index that I will not be able to delete will be nothing but the upper bound of the prefix sum till here, that is prefix sum till index I minus 1 plus B of k. If you simply do an upper bound of this in your array, or basically in your prefix sum vector, so you will be able to reach to an index that you will not be able to remove if you have started removing element from index I with the k value as k. Do you all agree with me in this? Because if you have started from I, you can remove maximum elements till the sum does not exceed bk. So if you have your prefix sum vector calculated, so just to know to the next index that you can't remove if you started removing elements from I, for that you will simply do an upper bound of prefix of I minus 1, that is prefix sum till index I minus 1 plus bk in your prefix sum vector, and you will be able to reach to this particular index, that is the next index which you will not be able to delete. Do you all agree with me in this? So can I say that this value, if let's suppose this next index that I won't be able to delete is j, can I write dp of j as nothing but minimum of whatever is the value of dp of j, comma, whatever was the cost till removing all the elements till I minus 1, that will be stored in dp of I, plus whatever the cost for deleting all these elements. What is the cost? M minus k. So I will just update my dp of j like this. So I will just run a for loop for every k. And for every k, I will run a for loop for every I. And just keep on updating my dp of j something like this. And at the end, my answer will be dp of n. And this is how I am going to solve this question. This is the approach to this question. So let me quickly jump onto the code. So as you can observe, I have taken n and m as input. So n is the size of array A, m is the size of array B. So I constructed two vectors A and B of size n and m respectively, took the inputs of A and B, then constructed my prefix vector or prefix sum in array A. So this is a prefix of 0 is A of 0. And for every index from I equals to 1 till less than n I plus plus, prefix of I will be basically prefix of I minus 1 plus A of I. Then I constructed a dp value and I initialized it with some maximum value, let's suppose 109. And I told it that dp of 0 is 0. Then I went over all the possible k values. So my k values will start from 1 and it can max go till m. M is basically the size of array B. So your k value can maximum go till m, right? So I just iterated over all the possible k values. The maximum sum of elements I can remove if I am having that particular k value is basically stored in B of I minus 1. Since I have taken the array B as input as 0-based indexing format. So I can say the maximum sum that I can remove if I am at a current k value. So it will be B of I minus 1. Then I went over all the possible values, that what is the element or what is the index from which I am starting to remove the elements. That as I told, that if I am having any particular bk, so I can remove any subarray. So if let's suppose you are having elements as a1, a2, a3, a4, a5, so you can remove any subarray whose sum does not exceed k. So let's suppose if I decided to remove this subarray, so basically I am starting with I is equals to 3. So if I am deciding to remove this subarray, so do you all agree that this subarray should already be removed? So if this subarray is already removed, this particular dp value, that is dp of 3, should not point to the maximum initialized value. It should not point to 1e9. Since I initialized my dp to 1e9, so it should not point to this 1e9. So I am just iterating over all the possible values from which I will start deleting the elements with this particular k value. So if my dp of g is 1e9, this means I can't delete elements from here because the earlier elements is only not deleted. So in that case, I am simply continuing. If that is not the case, I am just calculating the index, that is the next index, the index that I will not be able to delete if I started deleting from j. So For that, I am just simply doing upper bound in my prefix vector. So all pre basically is pre dot begin comma pre dot end. And in that, it will be sum, the number of elements in BK basically, plus the sum of elements that were already deleted. So if J is 0, then the sum of elements already deleted is 0. Otherwise, it is prefix of J minus 1. And to get the index, I am just subtracting prefix dot begin. So if my index is J only, that I started deleting from J, and the element that I will not be, the index that I will not be able to delete is J only, in that case, I am simply continuing. Otherwise, my dp of index will basically become minimum of whatever is the value of dp of index, comma, dp of J, because I started deleting from J. So whatever it was the cost for deleting all the elements from 0 to J minus 1, it was stored in dp of J. So dp of J plus the number of plus the cost of deleting the elements till idx, which is basically m minus I. Because if I have current k value as I, so the cost is m minus k. So I'm basically adding m minus I. So I am just updating my dp of idx with minimum of dp of idx comma dp of J plus m minus I. Once I'm done with this, if my dp of n is still initialized to that maximum value, so I'm just updating it with minus 1, because it's told to me that if you can't delete the entire element A, you need to output minus 1. And I know that dp of n stores my answer. So if it is still storing the maximum initialized value, then I am just updating it with minus 1. And at the end, I am simply printing my dp of n. So this is the solution to this problem. So do you all get this? Any doubt? So that's all from the discussion. I hope all of you loved it. So thank you.